Uh, Hi guys, I want to do a video, maybe some theory, maybe some rambling along with theory, maybe the theory of rambling. um, I want to talk about quantum mechanics and related to quantum computers a little bit, not much, but a little bit. Um, in things in our world that medium distance between the micro and the macro, we're in between the quantum or the very small and the relativistic or the very large astronomical or versus the very small subatomic worlds. We're kind of living between the two. We're kind of like one over one, whereas the astronomical is 1/0 and tending to infinity, and the uh, quantum is 0/1 tending towards zero, but not infinity for the universe and not zero for quantum mechanics, but close to it. And I want to explain something about quantum stuff. Um, Quantum means quantity. It means that particles in quantum world are only allowed to have certain values. They're not allowed to have anything in between. So they can only go from one to the other, and it happens in zero time because they can't take time to travel from one point to the other, because that would mean being in between the points, and that would mean they're not quantum, but they're linear, or they're continuous, and they're not. They jump from position to position without any time going by, different than what we experience in the medium world that we live in. But because they can only have certain values, and it takes zero time to get from one to the other, guess what? You can have something called a superposition, where something has both values at once. Like Schrodinger's cat. The cat that's poisoned in a box is both dead and alive until it's observed, and then it has to be one or the other. But until then, it can be both. It's not dead, it's not alive, it's both. Or it could be one or the other, or any combination of that, or it could be both and any combination of each of the others to make a both dead or alive. It's called superposition, and it's illustrated by a Bloch sphere, BLOCH, Bloch sphere. And I don't know why I have this board. Maybe I should start over without it. Maybe I'll use the board though. A Bloch sphere is a way of illustrating superposition for maybe for quantum bits in computing. A bit of normal in classical computing is 0 or 1, and quantum bit, which is a bit for quantum computers, the bit can have a superposition when it comes to being 0 or 1. It can be 0, it can be 1, or it can be any other probability combination of 0 or 1, and it can have different probabilities of combinations of 0 1, or being 1 or 0, or being 1 and 0 at the same time, or being any particular combination of 0 1 at the same time. It's illustrated by a Bloch sphere. Bloch sphere is basically you start with a classical circle of x and y and iy complex thing, and then you make a z coming out of the page, and that would be another axis that makes this sphere, with one surface, one major intersection being a complex diagram, the other being but then protruding out of it is from the z direction, like the right hand rule, x, y, z. Z is the thumb. Z comes out here, makes a sphere, and you can have rectangular not rectangular, cubical coordinates. You could say x, y, and then z to make it to plot a point. But since they all have a radius of 1, because it's a unit sphere, you could say the radius is 1, and the only variable is you have one angle theta, which is how far it is along, rotated about this axis, the z-axis. In other words, how far left to right is it rotated along the z-axis. And then once you know that, how far is it rotated along the x or the y-axis? In other words, and that angle is called phi. the angle that's wait, no, phi would be the angle around the y. Yeah, the angle along the z-axis would be phi. Yeah. Along x or y would be theta. And then along z is phi, how far it is around in this with respect to z. So one angle comes out like this, and that's rotating around x or y, and then the other angle is around this way, which is rotating around z, which is the second angle that plots any point of the sphere. It would be like r, theta, phi. Those are all the variables you need. If the radius is 1, then you just need theta and phi. If you know the radius, then you still kind of just theta and phi be the governing things to know that what the sphere is without no other variables are necessary. And there's different variables and positions and states you can map out with something called the Bloch sphere, BLOCH sphere. And it's interesting to me. I haven't learned it all, but then again, who knows all about anything? But I'm starting to learn about it, so I think it's interesting. So while I'm at it, the equation of a sphere is if you have a sphere that's at 0, 0, that's centered at the origin, it's just x squared plus y squared plus z squared equals r squared. If you have a point that's the center that's not 0, 0, 0, it's whatever the a is whatever x value, and b is whatever y value, and c is whatever z value you have as the center. And then the equation becomes x minus a squared plus y minus b squared plus z minus c squared equals r squared. So you're compensating for the center not being the origin. If it's a, b, c is the origin, center of the sphere, then that's the equation of the sphere, where r is the radius of the sphere. And by origin, I mean the point 0, 0, 0. That's the point x equals 0, y equals 0, z equals 0, the very center of the graph. That's called the origin. The center of the sphere is just whatever point on the 3 space, not the plane, but the 3 space, the space that is the center of the sphere. And I'm a beginner at some of this, but then again, I'm pretty experienced because I understand Fourier transforms, and I know complex variables, and I know some systems engineering, and I know some math. So I'm not completely out of the water. It's like a fish out of the water, but I'm not completely immersed in the water either, because I'm not experienced with this, with computing and quantum computers. Qubit just stands for quantum bit. Qubit, quantum bit, spelled Qubit. Yeah. Quantum computers are interesting and more powerful than classical computers for several reasons. And one is they just have faster and more immense computing ability and speed, but they also can quantum entangle. Quantum entanglement happens when two particles get close enough together to trade energy. Turns out mathematically that once they do that, once you know the position of one, you know the other one's position automatically. That means they're entangled. They're related forever, and they're related at a distance that's not local, therefore called remote. Einstein called it remote. What do you call it? Weird remote. Weird remote. No, remote weird action at a distance, or yeah, weird action at a distance. Yeah, something like that. Where once they entangle, they're related, and one affects the other, and the other affects the one. They're connected, and if you know something about one, you know the same thing about the other one, no matter how far apart they are afterward. That's interesting, I think. Particles can do this. People can too. Just a matter of who entangles with who. It's like ASP. It's like reading minds. It's like knowing what's happening in the room when you're not there. Telepathy and telekinesis and all that. You know, telekinesis is making things move. Telepathy is sensing things from a distance. Like, I know how you feel when I'm not even in the room. Like, and there's quantum entanglement of people too. Tele means apart, or to move, or to transport. Pathy means feel, so telepathy, feeling at a distance. Kinetic means motion, so telekinesis is moving things without touching them, being away and yet moving them. I think there's a thing called psychic telemetry too. I'm not sure what that is. I'd have to think about it for a second, but I don't want to think about it right now. I think it's interesting. So, I love you guys. Peace, love, and rock and roll.